My name is Maciej Cytowski. I work at Pawsey Supercomputing Center, and I'm responsible for what is called scientific services part of Pawsey. So working with researchers who are using our supercomputing resources. So I guess I represent a kind of like a user view from the perspective of MPI, different MPI topics.
Hi, my name's Emily. I'm also at Pawsey. I work in the supercomputing applications team, so sort of underneath Maciej. My background is application development. I do computational chemistry type stuff, but also, we have to wear a lot of different hats at Pawsey because we're a small center. I was cursed by a wizard to have to write a lot of Fortran code, so I'm interested in new programming languages that might break that curse. And yeah, hopefully something nice will come along to save me.
I'm Joseph Schuchart. I'm at the university now. My background's in task-based programming models and MPI, and I have a weird affection with RMA that I cannot share.
Yeah, so hello everybody, I'm Pascal. I'm the quantum supercomputing lead here. So I'm doing quantum computing and HPC. My background is computational astrophysics. So I do a lot of the astronomy support as well, but it's also the user-facing side and infrastructure side as well.
Hello, my name is Christoph Niethammer. I'm from the High Performance Computing Center in Stuttgart. My original background is in quantum physics, and I switched over sometime to HPC, where I'm mostly interested in parallel programming with MPI. I'm an author of 2 test suites for MPI and OpenMP, and I'm happy to improve the MPI standard together with all the other people.
Yeah, hi, I'm Martin Schulz, Tech University of Munich. You heard my role on the MPI forum. If it goes to our own group, we're working a lot on tooling and tool improvements, tool interfaces, as well as the idea of the malleability and the adaptability based on excellent conditions, particularly for energy efficiency.
Hi, I'm Hugo from CEA in France. I am computer scientist and I work pretty well on optimizing codes and I'm part of the MPI forum also.
Yeah, so maybe I would like to ask first of all the audience, because we had a long talk and we do not have any questions. If there are any questions to our panelists here that you would like to ask regarding what you just have heard during the talks or during this whole conference here, or what you just heard what they said when introducing themselves. Yes, we have one question in the back.
So things like continuations, in particular, they seem to provide a framework for which we could support higher level distributed constructs much more easily, like we see in things like HPX. Is that a direction that you expect library writers to go in? Is there any communication with people like the HPX community?
Yes, we are actually working with Pika, which is a clone of HPX. And they have been using continuations in their branch. And it seems to work well. So I think we learned something in the process too. So that was good. Yeah, the more I can, get users that the more confident I am that it's actually going to be a good integration. I'm a little more cautious than others, maybe.
It's true.
So I'm not familiar with Pika, but is it because Pika and HPX is not necessarily trying to solve a problem, it's trying to solve a particular problem, but not necessarily a real world problem, like I'm going to model a star or necessarily. So is Pika the same?
Yeah, it's a framework.
Okay, because the continuation stuff, because I was going to raise a question for MPI about quantum computing, because this is a very new type of accelerator that is finicky, will be possibly integrated in or possibly not integrated in, and the quantum acceleration of a real workflow is an open question. That's why there's an X Prize. But it's one of the ones where tying into MPI, initially I thought it's going to be not an MPI. In the purview of MPI, it's better suited to a job orchestration tool, which talks to a full device, and then you orchestrate outside of MPI whatever's happening. But the continuation in the sessions might provide an opportunity to have something where maybe you do spawn a bubble that has the MPI compute that then will eventually, the QPU or the quantum computing device that will then do some stuff, return some results, But the challenge there is in terms of real world devices, the result return can take a long time, can be very quick, depending on how many things you do. You can get errors. So it can just perfectly say, oh, here's the result. I got zeros, which is nonsensical. So you have to post-process the answer. But there's nothing necessarily wrong with the answer. But that answer might tell you, I can't talk to the quantum computer now. I have to do a different route for my task because I can't trust the quantum computer right now. I got to wait for its calibration or something. That adds a lot of complexity to the idea of a tasking system. But there's some possibilities of kind of using continuation and sessions to kind of look at this framework. I was going to ask, have you guys contemplated this in the context of a very finicky accelerator that is temperamental, essentially?
I think the answer is no, but that's mostly because I don't have a lot of experience with in the quantum space. I don't know if Martin, when we talked yesterday, you said it's not really clear what role MPI will play, but.
So the continuation I have not thought about much because typically I expect this to be a little bit more long term. So this maybe a little bit too fine-grained, but once we get into the next generation of devices, could well be an option. We have thought a lot about the sessions part though. Because we see a need to kind of adjust resources as you go on. If you need some heavy compilation part, you need perhaps a couple more processes to kind of dig in and give you the compute power. You need to bring in a GPU potentially to do the compilation part. And then also, but then if things become more long-term, you may want to shrink down and let somebody else take over. So I think the ability of having the malleability of kind of being able to grow and shrink resources in sessions is the mechanism to do that. I think there's a lot of potential to help optimize these hybrid workflows.
Yeah. Oh, I see it. You want to say something later? No. Because I think the main thing for the sessions was really attractive is the idea of you could do this and grow by a QPU, but then get an answer and say, I'm not going to acquire another session that has the QPU because I actually can't trust the results. And so it seems a very interesting way, a simple way of saying, I got results returned. I can't, this acceleration didn't work. I'm going to grow another session which has some GPUs to then do this compute that I wanted. I take a different route to solving my problem. But then the challenge, of course, is then that wait time of sessions. If you have a finite envelope where everybody's trying to compute for resources and you have a scheduler that wants to try to do this growing of compute resources is another challenge because you're going to interrupt other people who have planned workflows and so on.
I think a related question that seems to me with these with MPI sessions really moving towards a scenario where you don't have like a static allocation, ideally, right, over the runtime. Now, it seems like there'd be quite a few challenges when it comes to sort of integrating that type of model with something like a Slurm or PBS scheduler. Has much been done on that front?
Yes, we're starting to look into this very much. I mean, the thing is, Slurm is very much the static model still, and we have actually extended Slurm to be able to dynamic grow and shrink, and it was a pain in the and so there are we said we developed a set of plugins that can be attached to that, but those are necessarily not standardized anymore, right? They may change the interface anytime. So it's been a mess actually to do that, but we have shown the ability to be able to do that. The question is how we move forward, and we would like to have this more in a stable environment. In this case, not so much for the quantum side, but we have a large project on energy efficiency where you want to grow and shrink the resources based on energy provided, energy demands. And so if you have less renewables, you want to perhaps shut down some of the stuff and be at a kind of a low energy level, right? And so there we're looking into other schedulers potentially. To go into sort of flux scheduler out of Livermore is something that has much more flexibility like this baked in. But of course, then you have to change your whole infrastructure. So we'll see how that goes. But I think we need to look into new scheduling and new integration, no communication patterns into that part. Yeah. And one thing to add what you said, I think there could be one thing what we haven't done yet and what we need to do is this negotiation API between the system as the application and the system. And there you could start negotiating basically by when could I get a quantum computer, or if you have a function, does it make sense to get an ion trap or superconducting, or a GPU, right? And then you can have this negotiation based on how much you're willing to wait, how much you're willing to pay, basically. But this is an interface that has not been designed yet, and has not been designed with quantum in mind. But I think we should do that.
Yeah, maybe to add, maybe there we have to look also into other communities like the cloud infrastructure, because they have already established concepts for service level and this automatic contracting, because you don't want to interrupt your workflow because nobody's there at night time to decide it's worth or it's not worth. So you have to automate also this decision processes then in the scheduling. So I think that's a really interesting work, and we have to see how we can integrate this.
Guess question, comment, sorry. But I think that all of the challenges you would have with a QPU, I feel like they'd be pretty similar to the managing a program where you wanted to say dramatically increase your GPU usage partway through the program runtime on a system where they're in demand. So you straight away, maybe you have some queuing problem, you have a wait time, you're having to negotiate how long am I going to sit there and wait for that. So perhaps in solving those more classical problems, right, where really solving something a little further afield as well.
Yeah, definitely. I think that there's a lot of similarities. The GPU still has the advantage of having many more GPUs than we have quantum machines, right? I mean, if you have something like here with quantum billions where you get one into every node, that may change again, right? But having these small numbers of huge appliances. So we're comparing this often to like if you have a Cerebras in a system where you have one node and 100 racks of normal compute next to it, right? How do you approach that one, and how do you kind of allocate that? I think that's a very similar problem, even though the IO problem around is completely different, but the allocation and scaling problem should be very similar. Yeah. So we can learn with the AI community, I'd say, not from.
I think the problems of availability or extended periods of unavailability are similar to the problems of fault tolerance. Of a resource falling over is similar to it not being there. And I imagine that the two approaches could inform each other in terms of how you put that in an API or how you resolve these questions.
There's a little extra complexity in that you could get stuff that is behaving perfectly fine, and you're proposing it on a given, let's say, an ion trap system, but the ion trap system is poorly behaved for the circuit. Nothing will tell you that unless you do that post-processing and decide, I'm getting noise. And there's nothing wrong with that system. There's no error messages other than really encoding. I have to actually look at the results and do a little bit of check to see if they're sensible. And there could be all this stuff where this gets where I feel like it's hard for MPI. I'm not too sure if it's MPI or job orchestration, where a user might just propose a circuit to run on a quantum device without a lot of knowledge of what hardware is best suited to it because they're not the expert. And then you want something to go, this is what you said you're going to run. I've looked at it. I've done some sort of analysis, and it's ill-suited for the superconducting because you need high connectivity. The ion trap is not available, but that's what it's best suited for. But there's a neutral atom one that's a bit noisy, but it's available now. And then you'd have to decide what is the acceptable, like run now or wait 20 minutes or 6 hours or 6 days. So that's why it's almost pulled out. That's why, like I said, I'm not too sure if it's MPI or really pulled away to job orchestration, which is kind of designed for not necessarily fast communication, but just all these little hooks that you might want to put into a particular task and saying, this is how you're going to run that little task. But the idea of doing both and really looking at it from both perspectives, I think is really critical for the end goal of essentially having a new accelerator that is a quantum-based one. Anybody else?
I mean, it's related in as much as still talking about MPI sessions. The thing I find kind of interesting about that is one of the most successful molecular dynamics codes in my field of computational chemistry is called NAMD, and it does not use MPI as its method of parallelism. It uses Charm++, which is a very, very different paradigm based around having an adaptive runtime with lots of work decomposition or over decomposition. And you can swap processes in and out dynamically as things, need to hide latency and, make it essentially the runtime's responsibility to overlap communication and computation rather than leaving it up to the application programmer. And that seems to have worked quite well for NAMD in terms of scaling up. And it seems like perhaps sessions could be a way to approach that within the MPI standard, having this more dynamic model of resource allocation. I was wondering if anyone on the forum would like to comment on that.
Yeah, that's exactly right. I think the idea of having this more dynamic thing is something we can build on top of sessions, right? Sessions itself doesn't do anything of that. Sessions is still a very static model unless you add this extra feature, and that's what we're looking into MPI 5. And it would work very well with a charm type model where you have, oh, I could use a couple more resources and I can just move those chars over there and then work there and the application doesn't change, right? So right now the problem will be that most of the applications don't do that, and so it will be very hard to port to this kind of model, right? And so the first step, what I see happening is kind of this intermediate step of having more these coarse-grained workflows where I can spawn another component or another UQ job or something like this, and just a little bit more resources, kind of because that's easier to get to. But ultimately, I think where you said I think we should go. The question is just what granularity, what do you want to have, right? This is this overhead trade-off. At the end, I think we need to leave this to the user. I need to buy the ability to make that decision on the user side. But I'm hoping it goes that way, whether it's MPI 5, 6, 7, 8, I don't know.
Sure. And what we can do also with the MPI session is to specify, for example, if you make a session and you say, oh, I will not use MPI data types, I will not use wildcards or stuff like that. Maybe your implementation can say, oh, okay, if you don't use that, I can optimize the critical path inside MPI to not check the matching list or stuff like that. So maybe we have to think stuff like that on MPI.
Maybe just because of this Charm++, which is more like, I would say, in the direction of OpenMP tasks, but on a global scale with dependencies. So I think we are progressing well with the MPI standard as we are getting more and more of interoperability with the thread-based community, especially with the continuations, which will help there a lot. So that we can get more interaction over the network also here in this direction. And continuing maybe together with OpenMP in a collaborative approach based on OpenMP tasks and accelerator extensions. So could be a path. And
I don't see MPI replacing Charm++. I think MPI can serve as a backend for Charm++, and we can improve support through sessions, for example, to actually grow the job. But our users will not appreciate us moving around processes, for example. And that's my understanding of Charm++. It's very dynamic. We can move around computation. Our users are very cautious when it comes to changing resources underneath them, right? So Charm++ works for some applications like NAMD. It doesn't, like the model doesn't work for everything. So we won't replace it, unfortunately. I had a different question though. You mentioned newer languages. I assume one of the replacements for Fortran could be Julia. Do you see anything that is lacking in MPI that could help users move to away from Fortran? Everyone's talking about how dead Fortran is, and it's still walking around quite alive. So I don't know who's doing the bad job. If it's us or.
I am tempted to punt on that question because I actually really don't like Julia as a programming language, and I think it is a very bad choice for replacing things. So that feels almost like a cop-out, and I don't want to derail this into bashing the Julia programming language and developers. I will say perhaps diplomatically, if we were to look at an alternative programming language like Rust, for example, which I have used quite a bit, both in production code that I've had to support here and in my own hobby things, I think the biggest thing that would help with getting MPI support in Rust is the new ABI stuff. At the moment, there are Rust bindings, but they are very irritating to use because they have to compile new bindings for every MPI implementation. And having a stable ABI that you can use that way would be a huge win for, ergonomics in terms of packaging, but also the MPI semantics. This is where I'm kind of interested with your work on RMA, whether you think it's possible to combine the memory safety and type safety you get from Rust with something like one-sided communication in an ergonomic way that's not just whacking everything in an unsafe box, putting a C wrap around it and saying, here be dragons. It seems like very, very different models of reasoning about code.
That is an interesting question. I'm afraid I don't know enough about Rust. My intuition would be that once you hit the network, you're going to be in unsafe territory anyway. So we can't take that away from you. Or once you leave your process boundaries, right? It could be shared memory as well. I don't know how Rust deals with that. But it's an interesting question, and I would be interested in talking about Rust a little more, and learning some about that. And the ABI will be a solved problem next year.
I hope you're right, particularly for other languages, but C. I just wanted to kind of put a call to action. And I think looking at new bindings is really important. There are some languages which have a community support, and we should support them as well. There's a call for C++, there's a call for Rust, maybe a call for Julia too. What we are actually experiencing right now in the forum, and this is really a problem, is we need expertise on these languages in the forum. Otherwise, we're going to make stupid decisions and make something that just doesn't work properly. We see this already to some degree with Fortran, because we have almost no one in the forum anymore who speaks really Fortran and knows all the dialects. There's a large community out there, but that's not necessarily overlapping with the forum. And so we need people who have interest in languages to actually join us. And if not the whole forum, at least the task forces on these individual languages, particularly the new ones, that have experience with that and know the model very well, so that we actually design something that fits and not just is another C wrapper around it. So that so if someone is interested in that, please join us and help us get this right.
Yes, we need people who have diverse language backgrounds. I'm not actually sure that we need to standardize any other language. I think MPI for Pi, the Rust bindings, and Julia MPI, or MPI.jl, they've shown that the community is perfectly capable of building bindings without the forum getting involved. Right? In a way, we have done what you said in your talk, right? There's a specification semantics, and individual languages can pick them up and provide their own bindings. And I think MPI for Pi at least is not just doing the function signature translation. So maybe we don't actually need to standardize Rust bindings.
It's supposed to be a panel, so I'm going to say. Yeah, exactly. No, I mean, I see your point, right? And I'm not necessarily mean that we need to put everything into the core standard, because we know how long that takes. That's just too slow. But at least I think there has to be a collaboration with the forum, because we don't know the languages well enough to do that ourselves. But on the other hand, there's so many discussions in the forum about these particular details of the semantics of MPI that probably people that just write a wrapper around it, or even if the wrapper is good for the language, probably don't know. And so there is at some point a mismatch in there, right? And I think there needs to be a collaboration between the forum that knows all the dark corner and dark secrets of MPI with someone who knows the dark secrets of the language. And then perhaps the right thing is a side document that defines this, and that if you do a Rust binding, please do it this way because we have figured out that's the right way to do it. But it has to be in collaboration with both sides, I think.
It is important that the language communities approach us and work with us. And I think the ABI is one of those examples where that was quite successful. Both Rust and Julia, not just them, but also the container people, said we need this, and then there was enough commercial pressure to actually push this. And I think this is a good example. Fortran MPI does have a bus problem, and we need to think about what to do about it. It might just go the same way. So Jeff Hammond is writing his own MPI Fortran bindings, and they might actually allow us to remove them from the standard, so that we don't have to carry something we don't understand anymore, right? And then they live in a separate world, in a separate document, in a separate implementation. It's not just people on the forum, it's also implementers that have, we have one person in OpenMPI who knows Fortran. And I pity him because he has to deal with all of this, right? If he gets hit by a bus, we can maintain it, we can carry it forward, but we can't improve it, and we'll have a hard time implementing new features, right? So moving those things into the community out of the realm of MPI, the core MPI I think is a good way forward, yeah.
I just wanted to agree with that and say I think it's probably best to specify as little as possible in terms of language bindings within the standard. Just sort of have this is the target at a very high level and let the community figure it out. And if there isn't enough community interest to organize it, then maybe that's a sign that it probably isn't worth the forum dedicating resources to it either. That's just my 2 cents.
And I wanted to ask a slightly different question, so changing topic a little bit. But so I wanted to ask about I/O, and basically about whether there is anything that you are seeing on the horizon changing in MPI in relation to I/O. And then I will mention 2 of the challenges that I think we see. So one is that the compute side of HPC changed a lot with the accelerators, but there were also things that are changing and changed on the I/O side. So with an example of Acacia, the system that we are using, so sometimes you don't write just directly to the POSIX file system, but maybe you can write to something else. And then the other challenge is that a lot of researchers that are using our systems are usually now not running a single application, but usually some kind of a workflow. And we see that I/O is becoming a huge bottleneck there because they do write stuff to disk and then read it with another application. We see tools that are being created by the communities where they try to intercept some of the I/O system operations and basically create bridges between those smaller applications. And now the question is whether there is any space of looking into these kind of challenges on the MPI side.
I'm loosely involved with the I/O working group. It actually just recently reconstituted. Quincy, what's his name, Cosio, who is now at NVIDIA, of course, kind of rekindled this interest in this. And from what I remember now, top of my head, two things that we're looking at is non-POSIX semantics for I/O. But it's difficult, right? Because you're loosening a lot of the guarantees that you're giving applications. And then there's some deprecation that we want to do, like split collectives. This is like this preceded requests, right? So it's very old. We should get rid of it, and we have a replacement for it. I think there's also some interest in object storage, but don't quote me on that. If there's interest, the working group meets on Thursdays, probably at a very inopportune time for Australia. But there's a mailing list and a Slack channel. So some of the discussions happen in the Slack channel. There's also GitHub. Every working group has a GitHub repository. Even if you can't join the calls, you can get involved there. So, and everyone would be happy to have. Actually, I think we'd be happy to have people from Australia involved. That would be great. Yeah.
Just comment on that. So the groups actually libraries, so like ADOS and HC5 not so much, but they are really focusing on trying to expand beyond just MPI-IO. And I tend to think that's the better approach, and that you have people who are dedicated to trying to do IO, who would be like, you've given me data from somewhere, and I'm going to try to put it there as fast as possible, or there as fast as possible. And they, I think, are well set to try to tackle that problem. But I don't know if you guys are chatting to them at all. Are you chatting to the HTF5 group or the ADOS group in these?
Yes, I think they are involved with that too. And I mean, one of the things that were floated, and I'm maybe I shouldn't go on record with this, is to remove the IO chapter, right? Maybe this is not the right place, and instead something like ADIOS should be the quasi standard to do IO on HPC systems. But that would be a big step, and we'd have to be very confident, and you know, applications have an easy time to switch over. Yep.
I just want to second that. I mean, it's something we talked about in other places as well. I think it's going to be very important for us to look for the future to really define what is supposed to be in the standard and what we leave to other communities to do. I mean, we had the discussion with languages before in the session negotiation part. There's also some stuff where do we draw the boundary. And for tolerance, for example, we made the decision, no, we're not going to fix application state. It's not a solution. We provide mechanisms to do that. And stuff like checkpointing IO is left to an external library, right? And that discussion will have to be happening in IO as well. What do we need to support? And how far do we want to go? And when do we make the cut to the other communities? Because otherwise we're just going to overload the standard, I think.
So this is one place where I do feel like, even though there's a legacy community that are doing MPI-IO pure raw binary, that's such a terrible format, because if someone doesn't know what it's been written as, you're like, well, there's no way to figure out what that information is. So I tend to think it's going to take a little bit, but it definitely should be one place where MPI says, we are not going to, it's not part of the standard, because we're going to let other people write how they move data from memory to non-memory, essentially. POSIX file systems, S3 objects, etc. And I think that would be an approach where maybe something MPI discussed, like, we're going to eventually deprecate this sort of discussion and description, but older MPI is still there, but eventually it's not going to be part of the standard. So, and I think if it moved a bunch of people to move to non-raw binary IO, that would be great, because then their data is sensible. Like, and they can try to read it elsewhere.
So what part of what I'm trying to think about and get to slowly, but is what do we need to provide in MPI to allow others to implement their things externally, right? Yeah. So I think continuations is one of those things that are really useful, because it helps you with orchestrating work in relation to MPI. Maybe if we can get proper one-sided support exposing lower network capabilities, that would help some people. And then the rest can be done outside. MPI, I think, has tried to hog all the features that were needed. And that was maybe before a time when, you know, we had vibrant open source ecosystems. That is now a thing, and we can rely on that.